Hi guys, today in this video we're going to see about classical cryptographic techniques, whereas for encryption and decryption. So let's get into it. There are five types of classical techniques, which is Caesar Cipher, Playfair Cipher, Hill Cipher, Rail Fence Cipher, and then Vigenère Cipher. So let's start with Caesar Cipher. So it involves replacing each letter of alphabet with the letter standing in n places further down the alphabet. Plain text is written in the lowercase and then the ciphertext written in uppercase. So it is an substitution cipher method called as a shift cipher. So the formula we are going to use here is C is equal to E of K comma P, which is equal to P plus K mod 26. So C is cipher and E is encryption, K is key, and then P is the plain text. So this is for encryption. And then for decryption, what we are going to use is P is equal to D of K comma C, which is equal to C minus K and into mod of 26. So here D is the decryption process. So let's take an example whereas plaintext is equal to Kritik and then the key value is 3. So in that formula we could write it as C is equal to E comma 3 E of 3 comma P, which is equal to P plus 3 mod 26. So encryption process, what we are going to do is as the key value is 3, we are going to shift 3 places the alphabets, and then we are going to write it like this, whereas the small a is pointed to the D and the small b is pointed to the E, and then like it goes on, and the last what we get is for W we get the pointer as Z. So after that for X Y Z we have to fill the values. So as we have moved 3 steps, so that ABC will be missing here. So that we are going to add it at the last. For X it is A, for Y it is B, and then Z it is C. So for this plain text critic, we could find the ciphertext as we could get the K as the value, and then we have to point it at N, so that the N will be the cipher letter of the critic K. And then like that for R, so let's find the R, and then we could see the pointed it's pointed to U, so that for R the cipher letter is U. So like that we have to do it for each and every letter in the plain text, and then we could get our ciphertext as NULWKLFN. So for decryption process we have the formula like P is equal to P of D of K comma C, which is equal to C minus K mod 26. So whereas K is the key, which is 3, and then the as it's a decryption process, we are going to get the ciphertext letter, and then we are going to point it to the plain text letter. So for example, if this is the ciphertext, we are going to check where the cipher letter N is there, and then we are going to find the pointed letter, which is the plain text letter. So if it is N, we could find it the plain text letter as an K, and then for U we could find the plain text letter as R, and then it so on goes. So we could find our plain text as Kritik from the ciphertext this one. So now the second thing is Playfair Cipher. So it is best known multiple letter encryption cipher method. So here we use the 5 cross 5 matrix for construction of using a keyword. So let's get into it. For example, in the encryption process, if the plain text is Kritik and key is Savita, first we are going to uh, draw a 5 cross 5 table, and then we are going to write the letters from the key, which is not repeatedly, so that as here we could see there as 2E and the 2A, but we are going to write it only one time. After that, what and all letters which is left over, we are going to add it in the grids, so that after that finally what we get is uh, fully filled 5 cross 5 matrix. At the same time, what we have to do is we have to write any one letter with another letter, because as we know in 5 cross 5 matrix that is only 25 boxes, but actually in our alphabets there is 26 alphabets, so that we should write it like this to fill all the letters into the matrix. So after that, what we have to do is as our plain text is Kritik, we have to take KRITHICK as a pair. After taking it as a pair, what we are going to do is we are going to use this table, and we have to find where the K is, and then we are going to take this row and then we are going to find where the r is, and then we are going to take this column. So this row and this column is going to meet it at an box, and that box has the letter m. So what we're going to write is m. So after that, what we're going to do is the reverse process. What Whereas in the cave, what we are going to do is taking we'll take that as an vertical strip like this, and then for all we're going to take it like an horizontal strip like this. So what we'll get is p. So mp will be this plain text cipher. So like that we have to do for all the pairs, and we will get an cipher text as MP, MA, BG, KP. So after that, what we will do is the same reverse process. We will do another table like this, and we will get our plain text value as an decryption way. So after that, Hill Cipher. It's developed by a mathematician Lester Hill in 1929. It is a polygraphic substitution cipher method based on linear algebra. Each letter is represented by a number modulus 26. So here it is a formula, whereas C is equal to Kp mod 26. So here what we are going to do is we're going to use the matrix method for finding the ciphertext values. So for example, for encryption, what we are going to do is let's take our plain text as Kritik and then the key as Savita. So in Savita, what we need to do is get all the numbered value for each and every letters, and then we are going to put it in an matrix. So and we are going to name it as K matrix, and then an A matrix as from the plain text. From the plain text, let's take K or I, the first three letters of the plain text, and then also and we have to also name this with the corresponding numbers. Like for k it is 10, for or it is 17, for I it is 8, and then we have to make an matrix as a, and we have to multiply this and for getting an matrix c. The c is nothing but the cipher text value. So after this, if we want, we could simplify it, or we can leave it as it is, and then if and then we get a cipher text as nje. If we simplify it as if we simplify, we could get an approximately 15, 11, and 6. So if we um, see with the help of an corresponding letters and numbers, we could get the letters as nje. And then for decryption, what we'll do is Ka is equal to C. So this is what we have already done. Ka, which is equal to C. So for decryption, the reverse process, so that C K inverse is equal to A. For finding K inverse, what we will use is use the formula as 1 by det K into adjoint of K. So by using that formula, we'll get K inverse as this value. So after getting this value, we have to multiply it with the C, which is a cipher text value. So if we multiply these two matrices, we'll get some values like 10.0058, 17, 8.0058. If we get an approximate value of this, we get 10, 17, 98. So this is what the A matrix. We could see here as the A matrix we have already written as 10, 17, and 8. So we are getting the answer as 10, 17, and 8. So likewise, we have to decrypt the message from using the Hill cipher, using the inverse methods and matrices methods. So this is how we will use in a Hill cipher. So the next one is Rail Fence method. It is a simplest such cipher in which the plain text is written down as a sequence of diagonals and then read off as a sequence of rows. The Rail Fence Cipher is essential no communication security, and it will be shown that it can be easily broken even by hand. So encryption, let us have key value as 2 and the plain text as Kritik. So as we said, we have to write the letters in a diagonal format. We have to write it like K, and then down we have to write it as R, and then again up we have to write it as I, T, H, I, C, K. So like that we have to write it, and then and then we will get the ciphertext. That's it. It's very easy. We have to write the first value as KIHC, and then continuing it by the second values which is RTIK, so that our ciphertext will be KIHC RTIC. This is what our encryption process be happening in a rail fence method. So for decryption, what we have to do is we have to take the ciphertext and divide it by half, so that what we'll have is KIHC in the left side and RTIK in the right side. So that we have to write this left side values at the top and the right side values at the bottom, and we have to read the letters using the diagonal format like KRITHICK, so that we could find our plain text value as cryptic using this ciphertext value by decrypting the rail fence method. So at the last, what we have is Vigenère Cipher. So it is a method of encrypting alphabetic text. It uses simple form of polyalphabetic substitution. The encryption of the original text is alone using the Vigenère square or Vigenère table. So this table contains alphabets written out 26 times in different rows, each alphabet shifted cyclically to the left compared to the previous alphabet, corresponding to the 26 possible Caesar cipher. It at different times points in the encryption process, the cipher uses a different alphabet from one of the rows. So the alphabet used at each point depends on a repeating keyword. So let us get into an example. So for encryption, what we have to do is the plain text will be Kritik and the keyword will be Savita. So the keyword Savita generates the key as Savita, as because the both keyword and the plain text has the same number of letters, so that our keyword will be Savita itself. So after that, what we have to do is we are going to do an write a big table consisting of all the letters like A to Z and A to Z at the rows and columns. And then what we have to do is if if it is A, and then we have to write as B. If it is B, we have to write as C. So if it is starting from B, we have to write from B to the end, and then if starting from C, we have to write from the C to the end. Like that, we have to write it totally. So after filling this table, what we have to do is, as our plain text is critic, we have to find where the K is located. Okay, where the K is located from the rows, and then where is S is located from the keyword. So that from the keyword as that's in the columns. So that K and then yes. So what we'll get is C. So our first cipher text letter is C. So after that, for R and A, what we'll get is R, and then A is R. So our second cipher text letter is R. So likewise, we have to do it for all each and every letter of the plain text. We will find our cipher text value using this Vigenère cipher, and for finding the decryption process, what we will use is we'll get this value as an input from the user or somewhere, and then what we will do is we will mark the values inside this graph, and then we will find out how the plain text will be there. So this is how the decryption process will be happening for Vigenère cipher. So this is what the major classical types for encryption and decryption using cryptography. Thanks for watching this video. Bye.